Good morning. Today we will be discussing the square root of a complex number. Now, as we have seen that all operations of complex numbers give us another complex numbers, that is, if you add, subtract, multiply or divide two complex numbers, we always get back another complex numbers. So, let us presume that the square root of a complex number also is another complex number. So, let us find what is the value of that complex number. So, consider a complex number a plus ib whose square root is to be found out. Okay. So, square root of a plus ib is equal to, let us say, another complex number, let us say x plus iy. So, squaring both sides we get a plus ib equal to x plus iy whole square, which if we open we get x square plus I square y square plus 2ixy, and this gives us a plus ib is equal to x square, but now here I square is minus 1. So, it becomes x square minus y square plus I times 2xy. Clearly, x square minus y square is real part and 2xy is the imaginary part of this complex numbers. Now, we also know how to compare two complex numbers. That we know that if you compare the real part with the real part and the imaginary part with the imaginary part, we get the required values. So, this gives us x square minus y square equal to a and 2xy equal to b. Let's call it equation number 1 and let's call it equation number 2. We need to solve the value of x and y to be able to get the required square root. Okay. So, now here we can easily see that we have x square minus y square. So, if suppose we are able to find x square plus y square, then we can solve to get value of x square and y square and further of x and y. Let us see how. Now, we know that a plus b whole square equal to a square plus b square plus 2ab. Also, so here we have a minus b whole square equal to a square plus b square minus 2ab. So, from here if I write the value of a square plus b square, what I get is a square plus b square equal to a minus b whole square. This goes to the other side plus 2ab. Okay. Let us call it 1 and let us call it 2. Substituting the value of a square plus b square from 2 to 1, we get a plus b whole square is equal to, in place of a square plus b square we will write a minus b whole square plus 2ab, but this 2ab is also already there. So, we get this and this gives us a plus b whole square equal to a minus b whole square plus 4 times ab. Now, here suppose, now this is the relation which you would have done in your class 9 or 10. We are using it to find the value of x square plus y square. Now, here we have the value of a plus b whole square. So, if we put a equal to x square and b equal to y square, we get x square plus y square whole square is equal to x square minus y square whole square plus 4 times x square y square. Now using this we get x square plus y square whole square equal to x square minus y square whole square plus this can be written as 2xy whole square. Substituting from equation number 1 and 2, we get x square plus y square whole square is equal to, here in place of this we will write a, and plus 2xy is b, so we get this whole square. Now this gives us x square plus y square is equal to square root of a square plus b square. Now usually when we find the square root we write both positive and negative, but here this being the sum of two square terms has to be only positive. So we have this. Now solving, now from 1 and 3 we get x square minus y square equal to a, x square plus y square equal to under root of a squared plus b square. Now from here by the method of elimination adding we get 2 times of x square is equal to this plus this, from where you can get the value of x as plus minus the sum of these two. Substituting this in second equation we get the value of y, and hence we get the required complex number. So let's take an example. Let's take one question from exercise 5.4. Now this exercise you will find in the supplementary part of this NCERT book, which is after all the answers of all the exercises are given. After that we have a few pages which are dedicated to the supplementary material. So it's towards the end of the NCERT book. It's page number 474 and 475 of NCERT. Okay, now let's take question number 1. We have to find the square root of z equal to minus 15 minus 8i. Okay, so comparing, now let's write it as, let square root of z, which is square root of minus 15 minus 8i, is equal to x plus iy. So comparing we get, so first of all squaring we get minus 15 minus 8i is equal to x plus iy whole square, which gives us x square minus y square plus I times 2xy. Now comparing the real and imaginary parts, real and imaginary parts, we get x square minus y square equal to minus 15, and we get 2xy is equal to minus 8. Let's call it equation number 2. Now also we know that x square plus y square whole square equal to x square minus y square whole square plus 2xy whole square. This gives us x square minus y square whole square is minus 15 whole square plus 2xy is minus 8 whole square, which gives us 225 plus 64, which is 289. So this gives us x square plus y square whole square is 289, which gives you the, taking square root we get square root of 289, which is 17. Let's call it equation number 3. Now from 1 and 3 we get x square minus y square equal to minus 15 and x square plus y square equal to 17. Adding we get, this gets cancelled, So 2x square equal to 2, which gives us x square equal to 1, which gives us x equal to plus minus 1. Now, when x equal to 1, 2 gives us from here y equal to minus 8 upon 2x, which is minus 8 upon 2 into 1, which is minus 4. So, this gives us the square root of z is equal to x plus iy. So, 1 minus 4i. This is first result. Now, when x equal to minus 1, then 2 gives us y is equal to minus 8 over 2x, that is minus 8 over 2 into minus 1. Minus minus gets cancelled, this gets cancelled, and we get 4. So, this gives us another value of square root of z as x is minus 1 and y is 4. So, plus 4i. It implies that the square roots of minus 15 minus 8i are 1 minus 4i and minus 1 plus 4i answer. With this, you can solve other questions of this kind. Thank you.